I guess I'll get started. So, welcome to Below Sea Level. This is a startup put together by me and Aaron. And, the purpose is basically to get together all the systems programming people in the city and also people who are maybe curious about this kind of stuff. Maybe hopefully demystify some of these things, make it fun. Uh, Today, we're going to try something a little bit different. Typically, we do like 45-minute talks or 30-minute talks. We're going to try to, I think, if this goes well, uh, every other month we'll do a front end party like thing where we'll just do some lightning talks. And if you want to put your name on, you can, or if you just want to show up with your computer, you can just jump on and be like, here's something cool I learned. And hopefully that will help us not to have to find talks for every month, as well as like give people a little bit of a lower bar for like, okay, I'll talk about something. I got 10 minutes, I can rant about something. Yeah, like I said, Devin's on his way, so I'll start, and when he gets here, I'll just kind of hand off to him. But yeah, is there anything you want to bring up? Or?
If anyone wants to speak in December 5th,
Oh yeah,
open slot.
December 5th, open. And then I assume January, if it doesn't land on like January 1st, then we'll probably go back to this format. Okay, cool. Yeah, let's get started. So, I'm going to talk about something a little bit weird today. This is the first time I'm talking about this in public, and I kind of put all this together like a couple hours ago, so it's all pretty fresh, so excuse me for that. But I'm going to talk about this project I've been working on called Chicory, and it's kind of my vision for Java and Wasm. But it's not like a thing I'm doing alone. So I started off doing this by myself. I sprained my ankle and I was like, I want to build a WebAssembly runtime. And then I kind of started like, finding all these reasons to do it, and got it started. But things really started to kick off when Andrea came on from Red Hat, and he's been doing a lot of work on this. And Thomas just came on. And he's been just started contributing some code. So it's kind of a team effort. We also have like some collaborators from other companies who've been giving us a lot of good advice. So yeah, not just me here. So let's talk about why you would do this. I guess I probably should have put a slide about like what this is exactly. So Chicory is just like a way to run WebAssembly modules in Java without any native dependencies. So it's like a pure Java runtime. So why would you do this? Well, there's kind of two patterns right now with WebAssembly that I'm seeing. So this first pattern is like what a lot of the serverless platforms and some other, this is kind of like the sort of WebAssembly replacing kind of Docker container sort of stuff, where you basically compile your application to a Wasm module, and then you ship it off to some platform to run it. It could be like an edge compute thing. It could be a server, that like an Nginx server or something that you host or whatever. But the point is, you're shipping it off to some piece of software that has the runtime. It's got everything installed. It runs it for you, and it's like an application. The other pattern that we're kind of more interested in Delipso is this sort of embedding pattern. So the idea behind this is like I have some code. It's not necessarily an application. I have some code like a library. And I've written this library in some language that can compile to WebAssembly. And I want to be able to compile that to WebAssembly. And then I want people from other languages to be able to use that. So I want to basically be able to compile, say, a Rust program, and then basically bundle it up in a Java jar, and then someone from Java can interop with it. And then take that same little Wasm file and put it in a Python program, Ruby program, whatever. So if you're a Java or Python developer, you pull down your normal package. You're interacting with this Rust code, but it looks like you're just interacting with your normal language. So the way this typically works right now, the way we're doing this in Nextism as well is we have all of our Java code or our kind of languages code, In Java, we have like a class, or like some JVM bytecode. In there, we have our library, our WASM module, kind of embedded in there. And then along with that, you ship some kind of native object, some kind of shared object. And you typically will ship this. So like this object might be like, it'll contain the WebAssembly runtime. So in this case, we have we're shipping our library with WASM time. So the Java user, the Python user, the Rust user, they're all interacting with this WebAssembly module that includes the whole WASM time runtime. And yeah, so you ship your jar, your Java jar, and you also ship along this native object, and you load it with FFI, and it's dynamically loaded. And yeah, that object is native code, and it has to be built for the particular operating system that you're using and the particular architecture. So it's kind of a pain for a lot of these languages. For something like Rust, if you want, you can statically compile it into the application. So it's not quite as bad. But yeah, this is a problem for these kind of dynamic languages. So this isn't all bad. I think this makes a lot of sense in certain cases because something like WASM time is a very fast WebAssembly runtime, and like V8 is another example, and these are written in Rust and C++, and running native code for these kind of things is really quick. And these runtimes are very mature, and they're kind of at the forefront of a lot of the specifications. The cons are basically, yeah, so you have to ship your library with this architecture-specific and OS-specific code now. So you can imagine what was just a Java jar, and maybe you chose Java because you don't have to think about all these things, but now you have to compile this huge matrix of all these architectures that you might ship this thing off to. And this might work if you have an application because you know where you're shipping it, but if you have a Java library that you want other people to use, it's going to be a real pain in the ass because you have to support every possible architecture that they want to use. And then on the runtime side, using FFI basically means that when it's time to call the WebAssembly module, your program, which is safely running in a virtual machine, has to jump into native code and then back. And there are a lot of problems with this. There's some security concerns about it. I mean, you have a lot of safety just being in the Java virtual machine. There are some optimization problems where if you're making that jump a lot, the JVM's pretty good at taking a big stream of JVM bytecode and optimizing that. And if it just has a bunch of holes in it, it's not going to be able to do that very well. So yeah, those are some of the kind of cons. So what you really want at the end of the day is basically you want your WASM library and just out comes a Java jar. And the person who's using this, they don't need to think about it. They don't need to convince anyone that this native code is secure. They don't need to worry about, oh, is this going to run on this weird Android phone or whatever? It's just normal Java. So how does this work? So how do you create a WASM runtime? First thing you need to do is parse a WebAssembly binary. So when I started this, my goal was to just build the simplest runtime I could. So I've kind of left some things out, but the first thing you need to do is actually parse the WASM binary. That's roughly what this looks like without all the implementation details. And we've basically built up a fully compliant WASM module parser. So now that we can kind of parse code and get it into a structured Java form, we can put it into some kind of virtual machine. And right now, we're starting with just a simple, basically, bytecode interpreter. So instead of compiling to Java code, we're basically just parsing and interpreting the bytecode itself. And it's basically just a big switch statement. And it's basically just kind of taking the WASM stuff, turning it into Java to do computations, and then putting it back into the WASM space. So you can see here's Here's how you add numbers, pull some stuff off the stack, some WASM values off the stack. We add them, and then we add back a WASM value. Yeah, same thing for memory stuff. Like we have our WebAssembly instance here, and we can like get memory and put memory and all that kind of stuff. Yeah, so what does this look like to use? So this is a pretty low level, this is a pretty raw, some pretty raw code here, but this is a WebAssembly module I wrote to count the number of vowels in a string that get passed in. So this is just an example of a program you would write. And right now we don't have any because it's like a agnostic runtime, we don't support any particular ABI, so you kind of have to design your own right now. So that's why I have this thing that basically exports like an alloc and a dealloc. So I'm kind of letting the runtime like know how to allocate and deallocate memory inside the module. Then I export this other function called count vowels that basically takes a pointer to a string, and it goes through it and counts the vowels in it, and then returns the count. And what this looks like in Java is you create your module and you instantiate it. It looks kind of similar to the way JavaScript, the W3C JavaScript stuff works in your browser. And there you can pass in host functions, but we don't have any here. And then you can get the handles to the functions inside the code with the get export. So we're getting the export for alloc and dealloc and count vowels here. We're getting a handle to the memory. We're just putting the string hello world into the memory. We're using alloc to allocate some memory inside the module, and then we're passing in the pointer with count vowels. We're passing in the pointer and the length of the string, and then out comes 3. So there's 3 vowels in that string. So this is like really low level. I have XDism support for it working. So like XDism kind of has its own ABI that makes this look more like a normal function call, but as a runtime, like we're trying to be agnostic so that anyone can bring their own kind of ABI to this. We can support future things like the component model. Yeah, so how do you make sure this works? Because like a runtime is, it can go a lot of different ways. It's like a really giant state machine. And there's a lot of operations and there's a lot of features. So the key here is basically WebAssembly has a test suite, and this is a bunch of tests that people use to like validate WebAssembly runtimes. And key challenge here is that these tests are all written in WASP format. We don't really have a way to parse WASP modules in our project yet or run them. But what WASP is basically, so WebAssembly has this format called WAT, the WebAssembly text format, and it's kind of like the assembly language of WebAssembly, and it also looks like Lisp. So like kind of a raw WebAssembly module, you can program it in this WAT format, and you're basically writing what looks like Lisp. And WASP is kind of this extension that has some other features on it where you can basically create a module and you can put some functions and code in it, and then after that module you can do assertions on that module. So what this is doing is it's creating basically creating a module with an export function called add, and it takes 2 64-bit integers, returns a 64-bit integer, and all it does is just expose the i64 add operation. So the actual test file has like one of these for every i64 operation. And it's just exposing it so that we can then invoke it from the outside with different parameters, and we can just see that all these values are correct. And there's a lot of these. This is kind of a small like version of this. But so yeah, so how do we deal with this? Because we can't actually like compile and run these. So basically what we did is we wrote a parser that takes these WASP files and then compiles them into JUnit Java tests. So from these WASP files, we can compile a bunch of Java code that runs these tests for us at JUnit. So we have like one test for each assertion. We can run all these, and when one fails, we can see like, okay, we're failing for these particular things. We can jump in and debug them. And we have almost 16,000 of these running now. So in the past couple months, we've like really just been kind of hammering all these tests, and we're pretty close to like going green on all of them. And like once they're all green, then that means we have like a basically compliant WebAssembly runtime. Yeah, that's how we've kind of bootstrapped it. Here's a little demo. So I took that count vowel program and I put this in Android because I'm kind of running WebAssembly modules in like on mobile phones is kind of an interesting thing for us. So let me see if this runs. So there's just a little Android application that counts vowels that you put into a and it's that same Rust program I compiled earlier. So even though we're just getting started, it's pretty smooth. It's able to easily, basically every time you type something in, it invokes that function count vowels and returns the count. Yeah, so that's it. So next goals, we're trying to pass all the tests. That's our next kind of milestone. I think we're probably like 4 weeks away from that or something. We need to implement a lot of validation logic. We've kind of skipped a lot of the tedious validation logic because we don't really need it just yet, but we need to implement it. We have like some performance improvements. I've been working on a ahead of time compiler, so this is an interpreter, so it can only be so fast. So what the ahead of time compiler will do is take that WASM module and then generate JVM bytecode directly that we can then run. And in the future, we can maybe even build a JIT out of that. But at first, we're just going to basically use an AOT compiler because that should be pretty fast. But that's going to take a little bit of time. Then some nice to have stuff. We're going to implement some memory improvements. We're going to look at like WASI support. I have just enough of WASI to like print hello world, but we're going to go in and like kind of implement more of that. Looking at garbage collector and thread specs, and then also like component model support. But yeah, that's it. Any questions?
Yeah. How
Yeah,
much,
go ahead.
How much does the runtime add to like the size of the library?
This one?
Yeah. So you're saying like you're a library author, and you're trying to distribute your code, and it includes this runtime with it. Is
Yeah.
the idea? So does the runtime like make the download a lot bigger, or just the code size?
Well, these do, because like a fully compliant kind of like like WASM time can be quite large, like tens of megabytes, and then you also have the fact that you need one per architecture. So depends on how you want to distribute it. You can dump all of them in there, or you can have different targets where people like, I'm installing this Python library, but with this particular like kind of native object. But yeah, these can be quite large. This pure Java one is going to be fairly small. I mean, it's just a Java library. It's just another dependency. It shouldn't be too large. So yeah, shouldn't be too big. Good.
If you were to like decompile the jar that you're creating with that awesome in it, do you think it will show you like there's a lib wasm in here, or will it try to decompile that Java code?
At the moment, it would just decompile the interpreter. But when we're done with the AOT compiler, it'll decompile into, it could be a way to like translate some Rust to Java or something, right? Like it'll decompile actual Java code.
Someone else's jar and they would use this, and I didn't know they use this and try decompiling it, would be apparent, or would it just try to like formulate Java around it?
Sorry, what were you saying?
If I like didn't know someone had used this
Uh-huh.
in their jar, and I decompile their jar, would it be apparent that they had used this and then like a WebAssembly module in there, or is it going to try to like rewrite that into Java code?
Or does it just say there's like a binary blob or something in there?
As of today, like you ship the WASM module itself. And I guess that will probably always be true. But yeah, when you decompile it, you'll be looking at the interpreter, not the code. But the code is in WASM. You can decompile WASM. There's plenty of ways to decompile it if you wanted. Does that answer the question?
It's been a long time since I've used Java.
Yeah. This does work. We have used this. They're like native. They're like Java native compilers that people use, and the guy at Red Hat has been doing that where he's compiled this to native code itself, and that works as well. So it's kind of a lot you can do with it because it's just Java. There's not really many restrictions on it. You got a question?
What is the recommended way of distributing WASM?
What do you mean?
Like, so you say, like, someone creates a WASM module, right?
Mhm.
And they want to send it to all these different, like, let's say, library creators or
Mhm.
application devs. They want to use it in their different, languages, runtimes, etc. How would they, like, how would they distribute these exactly? Like, is there maybe a package manager or something like that?
Yeah. So the question is, for people who probably can't hear, is like, how do we typically distribute WebAssembly modules? So like in this kind of other like application style thing, people use like OCI and like Docker looking things, and they reuse a lot of that infrastructure to do stuff. In this kind of newer world where you're just embedding a library, there are no real like set paths to do that. There are some package managers that are coming out. We've been contributing to one and like on the planning on one that's going to be like a WebAssembly package manager. But it's still kind of early. But ideally, the way that you distribute it is like as of today, like XDism is like, you distribute like the code and then the XDism runtime, which is a native object. And in the future, ideally, you would just pull down the WASM module and you just have some bindings in your language that are able to kind of talk to it. And maybe it gets wrapped in like, in Java it gets wrapped in a jar or something, but or in Ruby a gem or like whatever. But the WebAssembly code should be in there, along with some kind of runtime if it's not already on the machine.
So
Yeah, probably in S3 at some point. Yeah.
No, I got you.
Oh yeah, go ahead.
so you have the alloc and dealloc functions. They're, does that mean that yeah, can you actually, will runtime let the memory go out of scope so that your shared memory can actually be garbage collected, or will that continue to grow as you
So what this does, for people who can't tell, like because Rust really doesn't want you to do this. So what it does is I'm basically just creating like a byte buffer, and then I'm telling Rust, like normally Rust will just automatically add a drop after you use some object, so it automatically frees the memory. I'm telling Rust like don't free the memory when you allocate it, and then just return a pointer to this back to the host. And then when I deallocate it, I basically am just getting that vector back, and then I'm not doing anything, and then Rust will automatically add the free. But the way the standard library works, I'm not sure. It's up to the memory allocator, right? Because like what happens when you free here? I guess if the memory allocator inside the module is smart enough, it could reuse that code. But at the end of the day, it's normal WASM where like once the module runs out of memory, it has to ask the host for more. And like we support memory grow and all those normal operations. So if you make it too big, it'll like grow, the number of pages. But yeah, it depends on your memory allocator. If it's just bumping forward, and I don't know what Rust does by default, but if it's just bumping forward, then it's never gonna like reuse that memory if that's what you're gonna ask.
right, and it's never gonna actually release it to the host.
Yeah, so right now the way memory works is it's basically just it's just a big byte buffer that we have. And if you ask for like 10 pages, then those 10 pages are always there until the module's done. So inside of it, the module can like say like this is free and this is used. But from the host perspective, like they have no way of knowing or caring. In the future with garbage collection and some other things, that might be different. But yeah, right now, like if you ask for 10 pages, like we just assume like you're going to use those at some point until you die. But it does Rust by default. When you target WASM, it compiles with the memory allocator. So it's handling its own memory allocation inside the module. And then when it needs more, it just asks the host for more. Someone else had a question. Do you have a question?
Yeah, so the main idea is that you are trying to avoid having these like native code for someone who's programming in Java. They want to like stay in Java land kind of. So you're including like the runtime written in Java. Do you see like a future of doing that in like other languages like Python, and does that impact the performance as far as?
Yeah, it does impact the performance because like Java code is not as fast as like Rust code in most situations. But there are a lot of other things that or there are trade-offs that you can make. Again, like for that performance, you now need to ship your library with like all these different architectures. I've worked at some places where if you hand them a Java jar, they're just like, great, whatever. If you hand them a Java jar and some native code, they're like, never, you will never ship this. So it's like, there are just trade-offs that you can make performance-wise. And if you know that your modules like aren't going to be heavily impacted by performance, this is going to be a much simpler solution. And also, we don't know yet. I need to actually build the compiler and benchmark it, but I would suspect that in the long run, it will be faster in some situations because the JVM will be able to see the whole program as one, right? Whereas a lot of times when you call a WebAssembly module, it's like going into the module, coming back, going into the module, coming back. So you got all these jumps in between these two kind of chunks of code. And yeah, the JVM doesn't really know what's happening. You can't really optimize any of that code. There probably could be some situations where this could actually be faster, but
it could just
it's hard to say.
JIT the runtime itself into
Yeah.
the
Yeah, and it also would decide when to do that as well. Like it would decide to do a quick baseline compile and then optimize it if it's like a hot path or whatever. Like the C2 compiler or the C2 JIT kicks in and starts, optimizing the code. And Java can be fairly fast, but yeah, we'll see. I don't know yet. I just suspect that for certain situations, there will always be a case for a native language runtime. And I think a good example of this is WA0, which is a Go native runtime that doesn't have quite all the same trade-offs, but it does have some of the same problems where to use something like WASMtime or V8, you need to ship with CGO. You have a lot of complications with that. And they've been able to push WA0 to be pretty quick. And for a lot of people, that trade-off is worth it because it adds a lot of simplicity. You can just keep doing your normal Go stuff of compiling static binaries and doing everything in a very simple way, keeping everything in the Go ecosystem, using all the Go performance and profiling tools and all that stuff. That's another thing, all these the JVM has a lot of tools for performance and profiling and a bunch of other things that you kind of lose when you have a native code. But yeah, I'm basically just, making the bet that there will be trade-offs where this is going to be worth it for, I think, quite a few people.
Can you promise that this runtime will always be called Chicory?
No. Yeah, it is a nice little nod to New Orleans. You're welcome, everybody. Yeah, there's a lot of Java puns or coffee puns in the Java world, so thought I'd do a little New Orleans twist on it. Yeah.
That's good.
Where's the repository now?
Oh yeah, so this is all private. I'm gonna open it up tonight, and we haven't we're not really gonna announce this yet. Maybe once everything goes green and we're kind of ready for it, we'll announce it. But tonight I'm gonna open the repository up, and we have like a chat that we'll open up as well. Start getting like early contributors. So if you know anyone who's like a Java person, like I think your brother might be interested, send them our way. We're looking for early contributors. I already texted Russell, so.
Was the JUnit suite something you guys wrote, or is that part of the WASM time? Is that a sort of runtime that you're pulling in, or
So JUnit is like what people use to do unit tests in Java.
I'm talking about like the actual test suite itself?
Oh yeah, so
Did you
this.
write 15,700?
No. This is the test suite that people use to validate WebAssembly runtimes, and it's written in what's called WAST.
Yeah.
So we basically go through and we compile these modules, and then we transpile these assertions into JUnit Java code.
Okay.
So it's like a compiler that pulls this repo down and goes through. And I think there's around 30,000 or something of them, so we still have a few to go. A lot of them are we're probably not going to implement, but we're getting close, I think.
Kudos to whoever wrote 30,000 WASD tests.
Yeah, I assume there was a little bit of generation on their side somewhere to generate some of these assertions. But we're also going to eventually look into fuzzing.
Which is essentially where I discovered this paper. But Andy Warfield is the fellow that gives this talk, is a AWS important person or whatnot. But the thing that I found really remarkable about this talk and this paper and this problem is that essentially S3 is made up of several hundred microservices. So there's a ton of different engineering teams working across a ton of different places and spaces to sort of present to our consuming selves a very simple, straightforward interface with very kind of straightforward and simple guarantees. So one of the things that he goes into detail kind of later on in this talk, after sort of walking through the growth of S3 over time, is this paper here, where essentially Shard Store is the name of the Amazon service that they're rewriting, but the important part here is that buried in this not so many interesting pictures and headings is them providing a sort of property-based testing and sort of executable spec experience. So the idea here, which I didn't have a chance to actually filter through the paper to give you a good bullet point, so you just have to talk to me and believe it, is essentially they can design the invariants that they want to provide in their storage system as a set of sort of API calls where I say I'm going to do a write with some shard and then read directly after, and maybe I break something along the way and things should support or be green along those pieces. And so they ship out this sort of sidecar where you update your service and then execute that, and if there's any sort of failures there, that gives them something to dig into that they're not maintaining the spec on. I work in a semi-large engineering organization. There's probably about 3,000 engineers in there. And one of the things that we recently have been embarking on is securing our data warehouse. So we store a lot of objects in S3. There's millions of tables, something to that effect. And one of the biggest difficulties that I've had in maintaining sort of a clean experience as we roll that out is this idea of an executable spec. And if I were able to sort of go back in time to the start of this project A lot of people mention that POCs are dangerous because they often sort of make their way all the way to production. But I would argue that in terms of an acceptance test, a POC going to production is completely fine, because what you're trying to provide is this sort of, not at the level of like an FFI contract, but essentially some way that you can give guarantees over time that are not based upon the engineer that you talk to, but like actually sort of executable from a systems perspective outside of what it is that you're trying to ship. So that's the main takeaway. I wanted to kind of open this up and ask if anybody had any experiences in sort of rolling out these types of systems, and this was like really timely with been talking about the runtime, because essentially like the development of that giant suite of acceptance tests is like sort of the validation of like the feature set that they're able to provide and deliver confidently to their clients. It just so happens that OSS wrote a giant suite of tests for you, but whenever you're developing a new system, I would encourage you to just build that first and then work backwards from it. So yeah, that's it. It's like a 5-minute talk.
So what? Yeah, we can get into questions. What kind of properties? Because like when I've done property testing in the past, you know, there's like identity test and like oracles and like other different kind of ways of doing it. Like I was talking about doing an oracle before.
Yeah.
With my runtime, where it's like, a testing oracle is like you have a known implementation of something, and then you have your kind of subject under test, like your, you know, like my WebAssembly runtime versus like V8 or something. It's like I put the WASM module in V8, I put the WASM module in mine, and then I just generate a bunch of inputs at it, and just record the outputs, and then just look at where they differ. So like bootstrapping some known working piece of software against some unknown. But there's other stuff too, like I've done in the past where if you do anything with encryption or compression, there's this idea of like you use one to test the other. Like anything that's like an inverse relationship, you can just like shove just all sorts of random data into it and like, you know, encrypt it and decrypt it, and it should be the same. What are they doing exactly? Like what properties and invariants are they testing?
It's actually pretty disappointing, at least in this paper, that they didn't go into details, and there's like nothing that I could
saw
see
some kind of
digging in.
Rust code in there or something. What was that?
Yeah, that was that's what they were talking about. Is the here we go. They essentially have like a reference implementation around the way that they're storing data on a disk. And so like in production, it's probably an LSM tree, but like in their reference implementation, they're using just like a hash map to store it. So it's like almost like a mock system, but you write one explicitly to be maintained alongside of the code, like similar to a test suite, but kind of like independent of that. And depending on the system that you have, I think kind of helps define what API you can get away with. But like the most valuable work that I've done in our suite of testing and like the big complex systems that we use is just like end-to-end acceptance tests that you can sort of run continually that help you detect like regressions over time, because it's not even necessarily that somebody's not able to deliver a feature into the system that you're looking for. It's that they're going to deliver some feature a year and a half from now that's going to break the one that they did before, and they're not going to understand why. And more importantly, you're not going to be able to explain to them why. You just understand what it was before and what it was now. And giving them something that they can get back the truth of, like with just a function call, is like insanely valuable.
So you're interested in like benchmarking changes against the way it currently works, kind of.
Yeah, I mean, you could do that.
Previously.
You could do that with an Oracle. So, like an example of this is we're doing a bunch of migrations for Spark. So we're currently on like a Spark 2.4 runtime, which is like out of date, end of life, old, etc. And we're trying to run workloads both on like Spark 2.4 and Spark 3.3 at the same time, and then kind of emitting counters and values to sort of compare and contrast the two. But it doesn't have to be like depending on what product you're working on shipping, like you can design the interface that you want to agree on at any level, be it HTTP, maybe it's like a function interface, or it's just like a suite of JUnit tests that somebody needs to be able to run. But yeah, that's
Got some questions here.
yeah. What's up?
What are these lightweight formal methods?
So first off, I guess we should define what formal methods are. Is anybody familiar with that?
Heard the words.
Yeah, the probably the best example I've seen, that as somebody that likes distributed systems probably has a good example for, is Jepsen. This is essentially a set of tools in a group that does analysis of distributed systems. And what formal methods are you essentially like specifying some invariants about your system. You're going to say, like, I'm going to create a user, and then these 3 things are going to happen in the system, and I can always expect these to occur no matter what happens in between. And so you define the desired end state of the system, and then what the formal methods provide are these sort of runtimes where you can fuzz your model and fuzz your expectations. So you have like all these assertions where, oh, this will never break, my user will never lose access to this table, and then I'm going to run all of these API commands in my model, and formal methods give you sort of a really explicit way to do that.
Explicit, kind of like you start with almost like mathematical proof, where you start with something.
Exactly.
This definitely follows that, and this follows
Yeah.
that. But is that different from the fuzzing, where you're just like throwing random stuff at it and hoping you find like a flaw? Or
I think it is. I mean, the way that they're really similar is essentially the property-based testing that Ben was talking about before, where you're saying, like, I'm going to expect that some set of parameters of this function, like if you just constrain it to a function, it makes it like really straightforward and easier to reason about. But that doesn't mean that you can't apply these same principles in larger systems. But let's like constrain our way all the way down to a language runtime and a function. You say, I'm going to provide you an integer, and it's going to be between like 0 and a billion, and these are the outcomes that I expect from it. And then with property-based testing, it can take that and then generate a billion test cases if you want to sort of exhaustively roll through everything, or it can generate interesting sort of edges of perhaps like the complexity of the function that you're trying to provide. Like, it's not always as simple as an integer, especially if you start talking about sort of composed object hierarchies and expectations about like what functions or features should be available on some of your models as they traverse through your state machine or not. The reason I mention Jepsen is like this is where I first discovered the value of formal methods, because I operate and ran at the time like Elasticsearch and Cassandra, which are these really fun systems that love to break in really insane and absurd ways that are hard to reason about. And the analyses and talks given from the Jepsen research was where I first heard about this, and it makes a lot of sense. If you take a graduate school course in distributed systems, you'll talk about like vector clocks and ordering, and computers are running all these things. So you can generate sort of the state of various executions that can possibly occur, and then just run them all if your system's fast enough, and then it'll tell you places where those invariants are broken.
Yeah, and fuzzers are also good at, if you say like, this is a string, this function takes a string, like when people typically write unit tests, they're just like, this function takes a string, I'm gonna put hello world into it, I'm gonna like check that it turns into something else, and then I'm gonna move on. And it's like a string actually could be like infinite
A
permutations.
fuzzer will send an empty string,
it sends
like
the weirdest strings, but it
oddball
starts with, like-
carriage returns. It'll send you things that are like encoded, not as UTF-8, like all sorts of stuff that will break your system that you won't expect.
Yeah, it's basically like it can generate a list of infinite strings and then sort them by the weirdest ones and start with the weirdest ones, the ones that are most likely to break your system.
Yeah.
And then as long as you want to run it, you can just let it run. but it's going to start with the weirdest ones first. So it's going to run the ones that most likely are going to break your
Fuzzers run
system.
against your actual system, right? Whereas
Mhm.
the formal method is you're running against the spec that you've written.
Yeah. Well, in those sense, like the fuzzer that's running against your system has an expected outcome that it's searching to discover is failing.
But my question is, the big problem with formal methods is that you can identify all the states in the spec itself, whether the spec actually represents reality. Is like,
Oh, yeah.
Like, do you know any work in like trying to model, like trying to the invariance in your spec actually represents?
That's what I found so exciting about this paper. This is the first time I had seen somebody like say, "Hey, we're leveraging like an executable spec in rewriting a really large system, and here's how we succeeded at it." And essentially, like they have a set of acceptance tests that they
The actual microservices, like the
are implementing against. Yeah, and so like you're developing your system independently, and then you like execute this spec, and it's like your service is supposed to listen on whatever port, and it's like here's the request I'm going to send to you, and here's the ordering in which I'm going to do, and I'll like fuzz all of these values because like they applied the property testing to the expectations to like the suite that they're going to be applying against. That way, whenever you run it, it presumably like helps sort of exhaust more of these edge cases where your oddball bugs should be found.
Are you looking at value behaviors or performance or like a combination of the two?
I mean, I think it depends on your system. Like, I personally am looking at both because a, a service that's unavailable and a service that is delayed are indistinguishable to a user. So, like, if you have a little bit of latency or your service is broken, like, depending on their workflow and how quickly your system should be responding, like, these are the same things.
Especially in like safety critical systems.
Oh, especially in safety critical systems, yeah.
So you were talking about before about like moving from a duplicated version of Spark to a more current version. If you're doing some tasks like ordering some set of values by some complicated like range
Yeah.
mechanism that has some flexibility in it, do you care if version 2.4 is giving you a totally different result set than version?
I mean, if it's
whatever?
non-deterministic outputs, I don't think it necessarily matters, and that's really workflow dependent. Like the problem there is that we're talking about testing a runtime, right? So we're like swapping the runtimes out. There's we can execute sort of the Spark validation of these things, but that validation is sort of for the spec of each runtime as it exists, not necessarily the way that our users have creatively expressed APIs that may not have been intended to be done that way. So I think in our cases, what we asked of our clients was saying, hey, you know, like tell us which jobs that we can run safely and target different outcomes, and say like, you know, we'll write your output here, we'll write your output there, and then afterwards we can analyze sort of the specifics as well as like the runtimes and things like that. But
Are there any situations where in an earlier version you have given up essentially and said like we just know we can't pass this set of tests like on this version, and then subsequent like if there's improvement or a fix, your next version you suddenly are passing those tests? How do you compare those? Or is it not happening?
So in our case specifically, this hasn't come up because what we're talking about is the sort of expected, like the efficiency of running the system, as well as the availability and correctness of running the system. So we're running, maybe I'm making these numbers up, like 100,000 workflows, and we run them on one version, then we run these 100,000 on another version. Like validating those things we can do kind of out of band just on how quickly they run and how expensive they are, and like what the various like profiles of those jobs are attributed to.
Presumably you don't have any jobs right now where it's like we think this should have worked, but it's not working on this version, and when we upgrade, we hope that resolves the issue.
Yeah. So what has occurred is that like in this testing, we have exposed deficiencies around the systems that we're testing upon. So like we've seen issues that have been uncovered where we're like, hey, this job took a lot longer, but it shouldn't have. And then we talk to the runtime team, and they're like, oh, hey, you know, there's a bug in the way that we're routing messages or something to that effect. So,
Like microaggressions.
I mean, I think that those definitely occur. It's not common, I would say.
I think it's Cortex.
Yeah, so one interesting bit of work around things like this is actually done by AWS, and it's there's like an article in their builders library around constant work rate. So the idea there is that you have a system in which you're applying sort of a steady state amount of work to it. Like you're always updating every domain. Like Route 53 was the example that they used. So it's like I'm going to like have this workflow that's going to like synchronize all the domains under a given hosted zone, and I'm going to synchronize like 1,000 entries every time. You may only have one entry in there, but we're going to send through this sort of static amount of volume. And the nice property of that system is that if your volumes increase, it's really easy. You just sort of like add another shard and everything works as intended. Like suddenly receiving a lot more requests doesn't break your system downstream. It's kind of like because you're always sending the maximum amount, you're just changing the values that are showing up. Your system is sort of like always operating inefficiently but consistently. So it depends on the problem that you're working on and the design that you're going for. That's why I was like really interested in kind of opening it up. If somebody here is working on a system that you have these sorts of problems with, I think being able to design the right interface that you can like execute over and over and over again to hold accountable your counterparties, whether it's like a vendor or another software team that you're working with, I think that like just helps keep everybody on the up and up, and you don't have to like have these sort of complicated discussions around like architecture sort of specifics. You can just say run it, execute it, there's the failing test, that's the logic, fix it. Yeah.
Yeah, this is my team is having this problem.
Yeah.
Well, so I guess the question, like, one of our biggest respects is, like you said, they aren't always accurate because often we are starting before the spec is complete, or it's like, you know, like a tool give us, or that it's not, or they edit it during it, or the person who did it, like, didn't really have enough information because
Yeah.
they lived in their brain, and then you're just going back to the code, trying to figure it out, and it's a lot. It's a lot to figure out. People are like, well, if we had better technical writers, it would be easier. But this is like a really great way to just take all the uncertainty out of it and just focus on, yeah.
Exactly. I think that the other aspect of this that I've learned is like working code is more valuable than a document. You know, people say quite often, they're like, we need you to write this down. We want to like have this sort of clearly defined and understood. And it's like, I'll do you one better. I will clearly define the API and runtime that is occurring here and what I expect from you.
What do you do when you check that then? It's matching up with code where it's like, what does this do? Or
Well, so
what
that's-
percent? And the answer is like, it does the thing it does, but we don't know why or when.
Well, I think that's part of the key is like this depends on the client or the customer that you're working with, right? So if you're a platform engineer and your client is another engineering team, your interface may be a library, right? It may actually be just like a Java interface that you guys are saying like, here are the functions and here's the way that we expect these things to work between each other. And like you can maintain that interface with a shared test suite. But it could be that you're delivering this agent that's listening on a port and it's like, here's the API calls and here's the ways that they're expected to work. And the other team may be depending upon that, or depending upon sort of like as you guys evolve and make those changes. I think if you can find a way to encapsulate the logic that you expect from the system, wherever it's coming out from, and then be able to execute that quickly, repeatably, easily.
I never heard the term like executable spec, so you mean like literally something that you are.
Yeah, yeah.
That is awesome.
Like
So they have that, does it have it at the beginning, or is it like something they do once they figure themselves out?
Well, apparently Amazon figured it out at the beginning because they're a lot smarter at these things than I am. I did not realize this until deep into the weeds of like fighting through my 15th bug of implementation across like my third engineering team. Like I should have actually just written a spec to hand this out.
Like before they build the feature, like again, that's just the thing for us. Like we start out with an idea of what we think it's going to be. And we're going to call here, and the data doesn't make sense. Like we start with what we think it's going to be, and then you get here and you're like, actually, like this P19 field is really like this field,
Yeah, I mean, a lot of that really depends on the nature of changes and like what's driving them. So like if what's driving the changes for your product are your sales team, and they're like, I heard somebody needed this, so like we need to go this direction. That's a bit different than like someone having work to do that has like an expected workflow, and your app is just like kind of not meeting their expectations. So it's really context specific.
There is like I got pretty into property-based testing a while back, and one particular problem with some of these methods is describing your system as a set of properties is very difficult.
Oh yeah.
Especially if those properties are, like you said, defined by the whims of like your business.
Yeah.
Like if it's basically like a database that is not defined by the whims of business. Like there are certain properties that are written down in literature about ordering, linearizability, all these other kind of things, right? And like those things are like invariants that will never change no matter how Stripe changes, because I think he works at Stripe, right?
Yeah, used to, yeah.
So no matter what Stripe decides, it's like their databases should always work this way, right?
Mm-hmm.
But then when you get into kind of like doing these methods on just kind of like application code, that's where I feel like you need an Oracle, or you need some kind of known implementation where it's like someone somewhere says, this is how it should work, and this is correct, and this is wrong, right? Because if you can't actually like define that, you have no way to write these specifications, and it gets really challenging because writing properties is hard, and also there's this other problem where like the only way to express some of these things is through code.
Yeah.
So it's like it has to be expressed by one of us, but if someone else owns that behavior that's not a coder, it's like impossible for them to express like exactly the invariance of the system.
Yeah. I mean, I feel like you can get away, like, utilizing plugins, utilizing sort of configuration at certain endpoints, or certain like to control certain behaviors of your system. Like having the WASM runtime is a great example of that, where maybe you want to extend your system in some certain way. Like the places I feel like where that falls down the most are when users have like a strong desire to make some like customization or extension of part of your system that doesn't line up with what they're expecting.
Right.
But if you can like kind of get the core deliverable down about like, here's what the system does, here's how it works, here's like the invariant of the system, here's what you can always expect to be true. I feel like systems that can provide those things and hold themselves accountable to that are the most stable systems that I can build the most interesting,
They definitely
complex
are.
things
My-
off of.
My point is just that those don't often map to like features.
No,
It's like
no,
there's like
yeah.
Like your system, there's a part of your system that like at a lower level has these kind of fairly obvious invariants. Like a database, if you write something, you expect it to like be there when you go read it afterwards, right?
Yeah.
It's like these are fairly obvious invariants, but things like features that someone is like, hey, we need a feature that does X, Y, Z, and then it also does like A, B, and C. It's like, is that wrong? I don't know. It's like all these things are like it's much more complicated than it's really hard to like just create an invariant for a feature, right? Because there's so much space. The language that people use to describe these features to the engineers is not precise enough to describe like all the things it can or can't do.
Yeah. It feels like a really relevant tension for this group, which is essentially like if you're trying to like skate in between programming language or in between different like systems of people trying to get things done, like the process that somebody follows, maybe if it's written down in Jira, it may not be technical, but it may be like correct or complete. If everybody's following it, people are terrible at following those things. Maybe you need to automate that stuff.
We've all like at some point like looked up, like found some Confluence page, like exactly what we're looking for, and you ask them on your team, they're like, that's been done for 3 years, it's garbage, it doesn't work, why are you doing it, why is it there?
Yeah.
Because it's what I need. It's like, well, too bad.
Right.
I'm pissed now.
Yeah, there's also the problem of like your system is not what it's supposed to be, it's what it is.
Yes.
So like I've noticed that problem a lot where someone's like, oh look, it's a bug because it's supposed to do this. It's like, but that's already launched. Like people have built systems on top of it. This is what it is now. Like,
that is actually the biggest takeaway I've had from launching these large systems has been like you you can't trust what folks say. Like, just
Yeah.
execute it. Be able to like
Exactly.
reliably back it up and reason about
That
it,
is how it behaves.
and let it be deterministic. Yeah. Yes. Sorry, you've been like there for like an hour holding your hand
no,
up.
You're good. So I think it's like. Actually, I'm just gonna ask just one question.
Yeah.
But yeah, so in a sense, what are like the major alternatives there? I feel like it would be like kind of in a sense easier to conceptualize in comparison to what's like either out there or what's considered or other solutions to the kind of fundamental problem there is like what are kind of the other potential solutions that you have here beyond just using these kind of formal methods there.
I think it really depends on the system that you're working on, right? Because if you let's say you're managing a WordPress site,
Yeah.
like a Jira bug ticket is probably sufficient for you guys to like maintain an interface that's like reasonable about it.
But let's say like a scale of like Netflix, right?
Sure.
You're talking about, something because I know like Netflix uses like S3 on like.
Oh, yeah. Tons and tons.
So like if you had like if this paper didn't exist, or what would be either like I know you kind of had your previous solution there that you're kind of I would guess like migrating away from.
I mean, what we did in the past was integration tests and like trying to find ways to sort of like maintain these specific call sites. But the challenges, at least in what we were doing, is that we're testing both the platforms on top of us as well as below us. So like we have teams delivering sort of components in our like OS layer, and then we have teams delivering applications or products on top of what we're doing, and discovering all of the ways in which they use, we'll just say use, internal APIs are pretty remarkable.
Yeah.
So the interface is what's working today. One thing that I find really common is we have a very responsive Slack-based support and a ton of data engineers, and nobody shows up in the support channel and they say, hey, this job has never worked and I'm having a hard time with it. Could you help me fix it? What they say is like, this job worked yesterday, or it worked last week, or it worked like 5 years ago when Dave wrote it, and now suddenly it started failing, or like it started failing 10 days ago when I first noticed it, and now I'm here. So like, what can you do to fix it? So like to some degree, at least in the analytics world, we see this interface exercise as like people running a job and then it coming back as success, and they're like, this does the logic in the system I expect it to, so it should come out that way. Now, whether or not that's like reasonable to like scale and like run a really consistent system, I think is a different conversation. But those interfaces exist, right? And like people break them or twist them up or get them wrong all the time. The alternatives are your stakeholders saying, hey, this is good, and then what the executable spec, or like putting the effort into providing a programmatic way of validating these things. It means that you can not only for your own development work test any change, but you can like provide this to your product partners and say like, hey, here's like in your test suite in Jenkins or whatever, when you're like running your builds, just like add this little file here and just run this thing, and then if it fails, call me. Because that means that you're going to break something in production, and I'd rather find out now when you're trying to build it versus like elsewhere in prod. And then just run it in prod continually all the time. That way, whenever it breaks in the middle of the night because like your data systems change, then you see it. But yeah.
So the Shard Store team, did they build in the paper that hey, we just built this new framework that we customized to test S3, or did they use something? Are they publishing it, or are they just keeping it kind of like secret sauce for themselves? It's like, hey, we kind of.
I mean, they're pretty much just telling you like, here's how it went when we did this.
But they're not saying like how they. There's like no details or like.
No, like
hey, we have this fancy new S3 framework that you can test.
No, I mean, Shard Store is not up there. I do think that potentially some of their SDKs provide like really interesting interfaces that you could track and follow and implement against, but like they haven't provided like the example of this.
Yeah.
And I think it really depends on the coherency you're trying to provide. So it's like what you're getting at is you're saying like anytime you run this pointed at a certain endpoint or in a certain environment, I should like know that this component of the system works the way I expect it to. And if that's just like one team, cool, you just call that your test suite. If that's like a dozen teams, or if you're, provide an integration for your customers, and you're like, here's the APIs that we're using, and here's a mock that you can use to run locally, which will give you sort of the expected behavior of our systems. And then you can like test against that same thing. Yeah, it's just, write more tests. That's the answer, unfortunately. Yeah. But yeah, if you're thinking about writing a POC to validate is probably a better usage of your time, is my opinion.
Did they outline any failures, or they just say it worked?
Well, they actually outlined successes, which was the fact that like they caught some 16 crazy oddball like race condition bugs based on executing this like validation spec.
Out of curiosity, did they then say like, and we aim to fix speeds in release?
Oh, I mean, like, have you used Amazon before? S3 is the only service you can depend on, right? Like, it is the most reliable. Like, it was there at the beginning. Like, they launched it. They launched
This is being
EC2.
recorded, by the way.
They launched EC2, and then they launched S3, and we've just been like, we've just been loving S3 ever since.
You don't have a closet full of servers?
I would encourage you to give the talk a watch, which we'll send out in the Slack channel. But yeah, there's definitely a lot of like lessons and interesting sort of like platform learnings around ownership and like who's responsible for like maintaining some of these invariants. But like if the test is green or red, it just gets real easy. Like you hand it to them, it was green when I started, and then you showed up, and now it's your problem to fix.
All right, we probably got to run. It's 8 o'clock. Thanks, man. Really
Yeah.
appreciate it. Feel free to
No
keep
problem.
asking Devin questions after this. We're going.
Yeah, in
Going to
person or in
Rusty now.
Slack, feel free.
But anyway,
chat
take
about
care.
these things.
Bye, stream.